After going through this module, we have learned set. It is the collection of well-defined objects. Roster or tabular form. In this form, all the elements of the set are listed and separated by commas within curly braces. Set builder form. In this form, a variable is written to denote each element of the set, which is followed by the colon and the characteristic property, and then the whole description is enclosed within the braces. Empty set. A set is said to be empty set if it does not contain any element. It is also called null set or void set and is denoted by the symbol empty curly brackets. Equal sets. Two sets A and B are said to be equal if every element of A is also an element of B, and every element of B is also an element of A. Finite set. A set which is either empty or contains definite number of elements is called a finite set. Infinite set. A set which is not finite. It is not possible to explicitly list out all the elements of an infinite set. Subset. Suppose A and B are two sets, and if every element of set A is the element of set B, then A is said to be the subset of B. Power set. The collection or family of all subsets of a set A is called the power set of A, denoted by PA. Universal set. A set that contains all the elements of sets under consideration, that is, it is a superset of each of the given sets. Venn diagrams. Diagrammatic representation of sets is known as Venn diagram. These diagrams consist of rectangles and closed curves, usually circles, within the rectangle. The universal set is represented usually by a rectangle and its subsets by circles. Union of sets. The union of two sets A and B is the set which consists of all the elements of A and all the elements of B, the common elements being taken only once. Intersection of sets. The intersection of two sets A and B is the set of all those elements that belong to both A and B. Difference of sets. The difference of the sets A and B, written as A minus B, is the set of all those elements which belong to A but not to B. Complement of a set. Let U be the universal set and A is a subset of U. Then the complement of A is the set of all those elements of U which are not in A.